Hi, today I'm going to show you how to make this parametric tower in Dynamo. It's basically five cross section of a polygon with five sides, or a pentagon, where the base have a specific radius here and 180. Radius again 50, and you can change the radius and at any specific area of the whole thing here, as you can see, and Dynamo will reflect that back automatically as a solid here and as a structure surface of it. You can go ahead and change each layer manually, as you can see, and you can end up having any specific proportion that you want in the building. I hope you find that useful. Anyway, let's start doing that. So I'm gonna close that file and I'm gonna create a new file, and in it I will go and create a slider. I'll go with the numerical slider in case if you want something with more digits, so that's a good idea to start up with. I'm gonna call this one, so just change that. It's really important to name those, so I'm gonna calling this again, it's for radius, so it's lower radius, and you gotta program that so it shouldn't goes 1 or something. Let's go maybe minimum 10, and the maximum is 200, and probably each move in its light, it could be each 10. And from this I can go and create a circle, and it's a by center point and radius. And again, just I'm gonna keep the center as a fixed location. I'm just making a very basic tower. It's all share the 0, 0 as an axis. So that's it. That's what we need here. And you notice that Dynamo immediately create the circle for us with a specific radius. Now I will select both of them and then hit edit, copy, and then I'm gonna paste that here, and then paste that again. And I said in the beginning we need 5 sections or cross sections, so we need to do this process 4 times actually. So those 2 are for the lower. Let's say this one, I'm gonna rename it and I'm gonna call it mid, and this guy, the last one, is the highest one, so we're gonna name this to highest or high. So again, those, all of them, if you notice, are located in the same place. And let's say this, let's go mid-high. And that's the low, and that's the mid, so the one in between, let's call that mid-low. Again, it's just naming, so feel free to change whatever you want. Now that's them been created all, and they are all located in the same place. Go ahead and give whatever value you think you need. Let's say the lowest one, let's go with 180. Let's go, this is 50. And then let's go smaller, so 40. So 55, and the final one back to 50. And as you can notice, if you go back to this enable background 3D preview, you're gonna notice that all of them actually sitting in the same plane with a different radius, and 2 of them have the radius of 50, so it's okay. So those, it's really good as nodes to be separated and to be isolated in this area, as they are representing one thing, which is the feedback, or the material or the nodes controlling the creation of the circle and the radius. So you can later on, we're gonna come later on and make a group for them. Just it's easier for us when you go back to see that, and we know what we did. So now we need to translate those circles vertically. So or make them move. So translate again here. I'm gonna use this, which is the XY thing, which is the easiest one. And basically it's all what it's need two things, which is the geometry itself, and it needs the z-axis. So I will copy this again and paste it 4 times. So that's 1, that's 2, that's 3, and that's 4. And then we're going to organize each translate in front of the circle itself. So we go like that. So now we can connect this one, this one, this one here, and so on with the geometry. And the last one is the lowest. Usually it's actually sitting on the level, on the 0, 0. So that's a mistake. So it's just remove it. You don't need it because we want it to stay here. Now in order to define the z-axis or the location of that and make everything related between the highest point and the lowest one and define equally, I will go to this guy and copy it again. Sorry, copy it and paste it. And I'm gonna call this, I'm gonna rename that guy, and I'm gonna call it floor level or floor height. And let's define it by 5. And then again another paste, and here we're gonna define a new thing, a new parameter, and I'm gonna call it number of floors. So how many we need as as a floor here? Let's say let's go ahead and make them 100 maybe, or 150. Sorry. Now, how to calculate this automatically? Up there in here, you have to basically multiply. That's the top or the highest level here. So you have to multiply all the number of the floor by the floor height themselves. So just double click here to define a code block and just give it A plus B, and that's A and that's plus B, as you can see, and take that, which represent the highest level of the building, and as you can see that we're connecting this, so that's the highest level, as you can have a go. And now let's say we have 5 meters. Let's go let's a little bit more, 200 floor. So that's the highest level we have, and it should be goes this one like 250. So that's something wrong. Yep, sorry, it's multiply, my bad. So now it makes sense. It's just yep, that's much better. All right. So again, what I've done here, a mistake, is just add. It should be multiplied, by the way. So it multiplied this by that to get you 1000. That's a correct thing. And you can even go ahead and rename this into highest level or highest level, whatever, or the highest floor. Now simply double click again. Now in order to find half of that, all right, which represent the mid, all you gotta do is again is A divided on 2. So whatever the highest, if you divide it on 2, you're gonna get the 500 or such, and that goes for the mid level. You gotta take this to the mid one. So that's the highest, that's the mid high, that's the mid. Technically, this guy here. That's the mid exactly. Now we have two things. We have the mid-high and we have the mid-low. The mid-high is if you calculate, if you have the average of both those two things. So again, it's the average. So I'm gonna go A plus B divided on 2. So anything you have in here plus anything you have in here, and you divide it on 2, so it should be 750. So you push that up to the Z or Z, and you gotta get this. You gotta push that away a little bit like that. Now, same thing. Whatever you have in the mid, if you divide it on 2, you're gonna have this one, which is mid here, mid-low, which is this one. So again, I'm gonna take this guy and I'm gonna go copy. I'm gonna have paste, and again I'm gonna connect this guy to it. So if this is 500, this is go to 250, and automatically I'm gonna connect it to this Z, and here we go. Now we divide whatever number you have here, gonna multiply it by that, getting the highest one, and those will be generated automatically. So let's test this or flex it. Let's go 100 here, and we're gonna see it's actually divided correctly. 150. See, 200. Now it's not 2000. 200. See, it's work perfectly. And now we have the towers being divided as the main center of the main location of all that is actually being defined correctly. Now, the issue we are facing that we still have copies of the circle created on the ground. So technically this is a translate, so I didn't define a center point, so I move it actually, which is a little bit easier. So all I need to do, like this is the geometry here, and that's its origin on the ground. So it would be smart of you to just remove the preview of those. So get rid of those previews from the ground. Why it's been deleted? Wait, that's the lowest. We shouldn't remove the preview because that's the only one here. We didn't have a copy of it here. Copy and move in the same time. That's what the translate do. So see now, those are removing here, being removed. So again, remove and then remove and so on. Much better. No more extra structure. Now I'm gonna use those circles to create my polygon. So polygon, and that's a polygon by points, and that's a polygon by circle. That's by point, and that's I will go by circle, which is this guy. So here again, so probably another 4. That's the second, that's the third, that's the fourth, and probably we need one here, the fifth, which it doesn't need any translate. So now just connect, and each circle with the polygon, and you notice that the circle, the last one we didn't connect it. Look what we connect. It's immediately gonna have its own, pentagon to it. Now technically we don't need the circles anymore, so remove them. And by remove them, I mean just get rid of the preview. We don't need to delete them actually. Just remove the preview. Make your work actually cleaner and better and easier to understand. So that's the main cross section, well being established and well defined. So go ahead and now define your groups. So gonna create those, and I'm gonna create group here, and I'm gonna name that as what they are. They are circle, or making circles, because you're gonna forget. I'm gonna guarantee that you're gonna forget in a couple of days or in a couple of even hours what you did here. So just add a group for it, or add a title to it. Here you have to go and create groups, and I'm gonna call this making polygons with translate. So that's easier and better by organizing it correctly. This is to define the height of the floor. You can also group them. Now those are an individual set or an individual geometries, polygons. Now we need to make them as one list, so we need a list to create, and it should have 5 items in it. So that's 2, 4, 5. And again, you know what to do, you have to connect those. And now if I select this, see all of those actually highlighted. So again, it would be really nice if you turn off the preview of those, because all as now are copied here in this list. So get rid of that. Sorry. See, now what we need to do is to create a point at each unit of length of this polygon. So again, I will go here and go for Curve.ByPointAtParameter, which is here. It's a point at parameter. What it actually need, it's need a list of curve, or a curve, which is this guy. And you can see if you zoom in that it's been defined as a point, as a startup point, as a default value of whatever this is, 0, which is the starting. Now you need to define a list of a point. So I will go with this 0.02. That's the first starting number. 2, 0.98, that's the end. And you have to give the intervals of 0.04. Just hit here, connect this, and it's going to be a mess in here, I know. And right click, and you have to go to lacing and make it cross section. By doing such, if you zoom in, I had this special combination here for you. It means if you go 0 in the first one here, it means from the starting point exactly here. And I don't want that, because I actually need to make those curves, so I don't want points to be in a curved location. I want to get rid of that. So by making this, I'm avoiding exactly starting from the beginning, and I want to start here. And by this number, I don't want to make it 1, because 1 is the end, which is the same as a starting point. So I want it to start away from the beginning and end away from that. And 0.04 created sorry, enough separation, or enough point as a distances to get this combination nice and neat, as you can see. And in a way, you now might notice that Dynamo did that for the whole sections that you have, and that's the beauty of it. You don't need to repeat that for each step. Now we go, and if I start to create curves now for that, you might notice that if I select this, that's the point, so I don't need curved in here. Let me start the transpose, or the other way of line, which is the vertical one, because those are the horizontal, are already been created. So I'll come here and have a List.Transpose. So I'll go just transpose, and it's gonna pop up immediately for me. I'm gonna connect. So the lovely, now instead of those rings, the list is gonna be vertically changed. So when I select, it should give me those points like this. Anyway, let's draw them so we can see them. So I'll go Nurbs and by point. No, NurbsCurves.ByPoint. Nothing. Okay. So be a little bit patient of how we get this. It might be annoying sometimes. So you have here 2 options, and actually 4 options. Let's have a look. It's other, or the first is just give you by point, and they are definitely opened and those guys are closed, so be careful. It's actually allow you to create, point. Those are technically open ends. If you have this, it's gonna have the same thing, but it's gonna make a full loop and close that. Probably you're gonna need both of them at a specific point. And this one, it allows you to do the same thing here, but with the changing degree for it. So 3 for the curvature. So I'm not going to need this. I'm gonna get rid of this for now. And I'm gonna remove it. I'm gonna keep that guy, and I'm gonna connect it. See? So what we've done, as you can see, is we change the list from a horizontal one. You can see we changed the list from a horizontal, the loops was like this, the list was like this, into a list taking the first one from here to the first one from here. That's what transpose does. And that's when this came and created all those vertical lines for me. But the most interesting things done here, if you zoom in, you notice that it didn't go to the corner. So if that's what you want, you can just go ahead and create a loft to create this, but that's actually what I don't want. What I'm gonna do is I'm going to divide those again, which is all those vertical lines. I'm gonna divide them again. So again, I'm gonna need this guy with this guy this time. I'm gonna copy them, I'm gonna paste them, just put them here, and I'm gonna divide those guys. As you see, those guys where are here, I'm gonna divide them with those points, and I will change this a little bit. So let's go from 1, probably from 0, sorry, to 1 this time, and I'm gonna keep that 0.4. Now let us create a List.Transpose again, because they are still vertically divided. I need them to return horizontally. So again, I'm gonna transpose them. So edit, copy, edit, paste, and I'm gonna connect them now like this. Now we need another guy of this. Now this is important, because if you're gonna choose this open one, it's gonna make it closed. Probably I need to show you both anyway, but I will have to take the closed one then. Let me show you what I want, and then probably we see the other option. See? Now let's zoom out. See now what we have. We connected, or the closed one actually caused the closure correctly, keeping this curved from each side of the tower. Is it? No, it isn't. Anyway, still open, keeping the last option open. Beautiful. Why? Because this is a Boolean value, and it goes for false, so it's easy. Just use true here and get rid of that. See? Now you're gonna find it close the loop. That's what we want. I didn't want from the beginning to have this edges, and I want that curvature, so that's the lovely of it. So if I return to this and substitute it with this guy, let's see what happened. Okay, and let me give this off. Let's see the difference between opening and closing thing. So see, that's again, it's a deal with it as an open, and we don't want that to be done. And plus, even if it's connected, the last one will be straight line. Even if I go back and fix this point series or whatever, adding another end to that line to end up from the same place, it's gonna connect it as a straight. It isn't gonna connect it as a curve. So I highly be asking you to be aware where to use this one and where to use this, the one that have ability to close from the one that have the ability actually to create an open. See, the opening one was really perfectly working well when we do those, because I don't want the line to go up and all the way down. That's an open, while those should be closed. So when you close, you should tell this node instead of this. Anyway, let's back to this guy, and make it previewed. Now that's lovely. With one thing annoying is we don't need this, you know, the main polygon, that linear edge, I don't want them. So because I was using them to create the basic structure for me, so probably you need to get rid of the list itself. So turn the preview off of it. See, better, much better here. As you can see, that's the cross sections is being created neat and clear for you. Probably you don't need to see the points, so again you might turn them off. That's one. So no more points. Two, and probably even the List.Transpose, we need to get them off because they are basically point transposing. That's better to see a clear mesh or a clear lines. The final thing is just to add the solid. You can make it surface if you like by loft, and they are basically this guy by cross section technically, and you just link, and that's it. You get your geometry done, as you can see in front of you here. And probably we need to make this manual. It's gonna go slower and slower, so you can zoom out. That's my geometry, as you can see, and it's well done and well defined with all the structure and division. You can again go back and turn off, you know, all the vertical and horizontal even lines if you don't like them to be existed. Just the vertical you like, or just the horizontal you like. Just a presentation and the ability to divide. I'm gonna use later on. Gonna use them to define, you know, the location of extra geometry to be divided on the face, or to use them themselves later on as separated panels or extra shells or extra elevation, double elevations here above the geometry. That's it. But it's a really good idea to flex a little bit from now and then. So just change. You're gonna see that it should work perfectly, and it should change. You can see, yeah, it should change the parameter the way you like and reflect any types of modification or any parameter you actually give. Create different forms with just the change of a slider. It's a really nice way of dealing with the parameters design, rather than making a one option or one fixed tower that you can deal with. You can make God knows how much probability you can do from the same option, or from the same proportion, or from the same tower design. I wish that you find this useful. Thank you very much for watching, and have a good day.